and eliminate any outside influences on your device for the measurements. So that's a main.
The chamber is enclosed, or I can see from the chamber, right?
This chamber right here. Yeah. Access. To the inside. Check stage.
Just the chuck.
Yeah. So, there's a difference in size of the chuck as well. That one is a 6-inch or 150 millimeter chuck. This is a 200 millimeter chuck or an 8-inch chuck. And another difference is on this one you have your auxiliary chucks in the front.
Oh, there was some setback.
On the back, yeah, exactly.
You also have the left and right, both you can see.
Right, yeah, left and right is the same. Yeah. Exactly. And then the aux chucks themselves are the same thing. They're identical. It's ceramic block, and then you have the aux fences in the corners. This one has it in the back right corner, and the left chuck has it in the back.
How about the shape? It comes out more, or like?
Just right where it is.
Oh, I mean like.
Oh, for your device testing and stuff. Yep, exactly. So you put it in right where it is. It's more for
so you can put it in the front only.
The front only, or from the top. Or you can if you have a small device.
We will have actually small devices.
Very small devices. Yeah, so it may be better to load from the top. And this plate also comes out as well. That may be a little, yeah, that may be a little bit easier for you. And the chuck also comes up with the chuck switch. So there's a chuck like that. It's a little bit better for you. Maybe a little more toxic. It's more designed for wafers. As far as loading from the front, it's a little bit easier and easier efficient in front. Exactly. In single bond, yeah, there's no real way to access the center of the chip. And that's probably going to be your best option right there. That can make it a little bit trickier also. Obviously, you're going to have your probes in there as well. But this plate, there's 4 screws. They're captured screws. You screw these up, and then this plate will come out and completely.
Better not to touch, like, leave as it is.
It depends, yeah, how comfortable you are working with it. You just want to be real careful with your probes when they're in here and your devices for sure. So, I don't know if I can get the pressure up there. Let's see. While we're down here, so you have your vacuum switches for your left aux chuck and your right aux chuck.
When you put one on top, then you do lock. Right.
That will turn the vacuum on, and then turn the vacuum off. Yeah,
from the left hand.
Exactly. And then this is the main chuck vacuum. Turn the main chuck, and again, that's just going to be for the center ring, or the very, very center of your chuck. When you turn this on, and similar to that station, you have a switch on the front. That's inside, maybe part. So the vacuum switch, where you can select the size. If you're doing a 2-inch, 4-inch, 8-inch wafer, and you can see some numbers right on the front. And right now it's set for 8. I want to push it all the way over to the right, which is center. So, which will probably, so that'll be just the center holes. So it's got similar 4 vacuum holes in the center of the chuck, just like on the other one.
Now it's good. Because you just start.
Wow.
when you go closer,
Yeah.
maybe increase the zoom.
Just a little bit.
No, the
Focusing.
focusing. Yeah. So when you go closer,
Mm.
Still there. Okay.
so where is the vacuum?
Okay. Let's see here. Let's see. You're looking fine.
Here. You see one.
Up there. Similar setup. The other chunk. So this vacuums activate those 4 vacuum holes.
The same.
With your switch at on C.
And we can use this for the small chips. Like,
Right, exactly.
and when you say 2 4 that means 2 4 diameters of the chip.
Right, yeah, exactly. And so it's actually, this one is 4, 6, and 8 for your
4, 6, and
selection.
8.
This
It's
one
the
is
bigger.
2, 4, and 6, and then this one's 4, 6, and 8. Yeah, exactly. Let's see.
And when you say 200 millimeter chuck, that means the width of the chuck is 200 millimeter or
Diameter.
the diameter?
Yeah, so an inch
Oh,
diameter
it's millimeter.
chunk. Yeah, exactly. So it's also a scope lift button here as well, which is a pneumatic lift on the scope. And I gotta make a little adjustment to that. All the cable tensions, I wanna do a little work on that. So it's just a pneumatic lift up and down 2 position. You also have a coarse focus, and then the smaller knob will be the fine focus. Focusing your microscope. And then there's also a zoom function. Kind of talked about. Yeah, it's got a very nice scope. Okay.
It's better now, I think.
You do a focusing function on this one as well, at the bottom, but there's really no need to use it. If you do any focusing, that's best to just use the focus rack here, the coarse and the fine.
Mm-hmm.
And so there is no switch option between like this, right? There is a switch in my scope or
There's no, yeah, this one
There's
doesn't
only-
have any eyepieces, so there's no
only-
shutter.
only the monitors.
Exactly. There's an LED source on the side, and that's controlled, or remote control knobs, turn the light on and off. You can also control the intensity of the LED.
Mm.
It does a digital camera, adjust automatically.
Millimeter focus.
Interesting. It's a lot better. Crank it up a little bit.
It's better, right? Vibration? Little bit better.
It's not stabilized,
Okay.
so we have to make sure that it's stabilized, right?
Yeah.
So I do that, so that's with the light all the way up. When I turn the light down.
Because if it's not stabilized,
Mhm.
if you're going to probe the
Yeah.
chip, then we are not sure why it's touching or.
That is really curious. So it looks like with the light very low, what I expect to see. That's curious, but if you turn the light up, so that's a good notation for your training. When the light all the way up, the camera's gonna adjust, but there's something strange going on with the video and it moves around a little bit. You get a little bit of a wavy effect. So I recommend, at least for the time
See-
being, using a low light setting.
See, Brian, whenever you touch that full station, maybe there or any, it starts like this.
It will move, no question, no
Yeah.
question. Yeah, this
Yes.
will cause movement,
Mhm.
yes, no question. But without touching or without any influence on that, you shouldn't get any kind of adjustment.
Mhm.
But touching this, yeah, that'll do, it'll move your probes, it'll move a lot of things, for sure. So, yeah,
So that much is not that much stable like this because this one was like in the sense very stable, right?
no, I'll do the same thing. If this is errors on here,
It's the same.
absolutely, absolutely. Yep, you'll see the same kind of effect on there. So, yeah, that looks good on a low light setting. That's very, very interesting. So I'll feed that back. I don't know what issue that is exactly, but I think that's a workable solution.
So what's the problem was that? Like if you increase the light, then it's
If you increase the light intensity out to the max,
oh, it's automatically adjust to the
and
Goes like
then
low.
you get that little bit of a wavy effect.
Mm-hmm.
So something going on between the light and the camera, I'm not sure exactly what, but a low light intensity, and it's just very low.
Mm-hmm.
That seems to be fine.
Camera
First-
and that light control can be replaced, right?
Yes,
Okay.
yeah, both the light control and the camera can be easily replaced and stuff. I have to understand exactly. So I'll feed back to the factory and just
Yes.
let them know, you know, with a bright light, we're getting this little bit of effect, you know, and what do they suggest you know,
Yes.
for that.
Seems like monitor, HDMI or station is okay,
Mhm.
only with a camera or controller. Maybe.
Yeah, something with the light intensity, what exactly is causing the issue, I can't really say for sure.
Mhm.
I don't know, I'm just curious, but we didn't see it on the other
Yeah.
light. Maybe it's got something to do with the LED itself.
And one thing, if we try to move these things,
Mhm.
again, can we see that it's like waving or not?
When you move it, it'll move around.
Yeah. Yes.
You see it?
At first time, it was.
Yeah, I mean,
waving, but-
anytime you touch, you'll see it's, you're not gonna get away from that. That's just natural. It's just an influence, you don't see that for sure, but then it should settle down. I mean, this here is much different. It's completely different issue
Yeah, that's
than,
different issue,
than
the
this. I mean, it's a totally separate issue for sure. That's really.
so we note down this and
Yeah, make a note of that, feed it back to the factory and see what they suggest. So for the time being, until we have a proper solution, yeah, the light setting and the digital camera will automatically adjust for it, for sure, for the different light setting. Okay, that's interesting. Also, you have attachments on the station for your positioner cables, which would be, for example, yeah, exactly. So these guys would be designed to hook up. And then typically, you know, you'd have your instrument in the back or on the side, and then you can come in. And then you can come in with your coming over your instrument connection cable to the back side.
that's like
And have up to 8 positioners, 8 probe needles. Generally, your setup has 4. You have 4 positioners, but it's capable for doing up to 8 individual
to
units.
purchase in the picture separately.
Yeah, exactly. So you have the capability. Right now, you have the capability. You have the equipment for 4 probe needles, DC needles. But you could do up to 8.
We used to also have like this hook.
Exactly.
So separately you have to attach that.
Oh, sorry.
Like this thing, like for holding this because it doesn't have this.
Yeah, I need to. Well, I'm gonna have you guys put them on. Actually, they're right here.
Oh,
So
so
install the arms and the needles as part of the training as well. So we'll do that. Okay, and I'll show you how those go in. So when everything is assembled, it's all completely enclosed on the top. So you're not even gonna see this portion of the arm or the needles themselves. Yeah. Okay, you can operate it with this out. If you're doing devices that aren't sensitive to EMI or influences from the outside world, you can take this right out and operate an open setup like on the other station, or you can have it completely closed up as well. So a little bit more, maybe a different level of expertise, I guess, or user to be able to probe in there where you can't see anything going on. Everything is going to be looked at through the monitor. You can't very easily see what's going on with your probes. These slides do come out. It's just magnetically attached here. So So you can see a little bit, it's not gonna give you quite as much view as the other station, but yeah, definitely a different level of expertise for folks using this station. It takes a little bit more getting used to. Okay. In addition to the focus on the side here, you also have an XY movement for the microscope as well. So this will allow you X and Y. X. And then there's also a thumb screw to lock it on the side, so you can lock it into position.
So it's not labeled.
Yeah, this cap is not in place. So yeah, that cap will be in place. All right. Let's see. Very important. Again, this surface down here is an air-bearing surface for your chuck stage. The puck for moving the X and Y is exactly the same as the other station. So you have a button on the left side of the puck. So you just depress the button and allow you to freely move the chuck around the X and Y. And then you also have a fine control for your X, also your Y. And then there's a fine theta control as well.
Like a little bit, right? Angle.
Yeah, 5 degrees.
5
It's
degrees.
not going to spin the chuck around. Yeah, exactly. It'll give you plus or minus 5 degrees to go.
So we have to put our chip by ourselves at the right positions.
Yeah, get it approximate. So, and if it's just a single eye, it doesn't have to be absolutely perfect because you have the probe needles, the individual needles you can control as well. So, if you have a wafer or something like that, you want that to be aligned. But a single chip, yeah, you get it close and then you can fine tune it. Yeah, for sure. Okay.
Regarding this ball.
So, yeah, let's go into that next. You read my mind. So, a couple features. The operation is very, very similar to the TS150. If you rotate the handle clockwise, counterclockwise, excuse me, we'll unlock it. Clockwise 90 degrees, we'll lock it, and it'll prevent you from dropping the platen. So that will control this whole platen where your probes are mounted, and you'll be able to move them up and down. So again, the whole throw from top to bottom is 3 millimeters. And then there's a detent about 3/4 of the way down. It's going to be 300 microns from the bottom. And then in addition to that, there's what we call a hover control. And what this allows is you can adjust how far from the bottom position of the probes you want to be. What I mean by that is on the side there's a 150, a 100, and a 50. So what that means is 150 microns, 100 microns, or 50 microns. The thumb screw here is currently set at 150, and that will determine, when you put this in, how far from bottom do you want to be? Do you want to be 50 microns above? Do you want to be 100 microns above the bottom? Do you want to be 150 microns above the bottom? This is primarily for wafer probing typically, and is designed to have your probes in focus and your device in focus at the same time, so you can do a fine positioning of your device under your probe needles. So it's designed for just very, very small, fine movements.
So this distance is from the surface to the needle distance?
So from the needles at the very bottom position, If I now, right now I have it set at 100, if I lift this handle up from this position, by doing this, I'm moving my needles 100 microns above that bottom position. So if you're contacting your substrate, then you're gonna have a little bit of overdrive, and then eventually you're gonna pick them up, but it's gonna be 100 microns above that bottom position, so. Currently set.
So where the screw is put, that will be the positions, right? If you put the screw in 50, that means you can go.
Then it's gonna be 50 above, so it's a very, very small gap. Yeah, it's extremely small gap. And then you can do 150 as well.
We have a spare screw, yes.
No. Do you need one, or?
No, I mean,
For this one?
in case we lost some students working and it was correctly.
Hopefully, maybe probably just leave it in one position, I would think. That would be the most common stuff, so that's kind of what our hardware control, and the main feature is just to be just barely off your pads.
Fine.
Have everything in focus, and then you can maneuver your device underneath the needles, and then once you got everything set, you can make the final drop into position.
And you said that the lever itself adjusts 3 millimeters.
Yep, exactly. So this detemp is going to be 300 microns, and then all the way up, that's going to be 3 millimeters. Yep, exactly.
Because it's a separate screw on the top to adjust like.
This one does not have
Doesn't
that.
have
Yeah, exactly. For the coarse movement, this one does not have that. But you do, what that one does not have, I neglected to mention, there is a Z control on the chuck as well. You have this chuck up and down,
Okay.
and then you also have a fine Z control to move the chuck up and down. I don't have a picture anymore.
Because you take this out, maybe you can put this in.
Yes. Thank you. So with this guy, and you have a 5 millimeter range that you can adjust. There's a small indication underneath
Yeah.
with a scale,
Okay.
so to see where you are in the travel range of the Z-axis. So instead of having the knob for the platen, on this one you have it right on the chuck surface.
So far in the Z-axis, we can move the chuck that 5 millimeters and the chamber by 3 millimeters kind of stuff. Not that.
The platen, yeah, exactly, 3 millimeters, and then you also have still have the positioners where you have 10 millimeters of travel. Exactly.
These are all options.
There's a lot of options. You have a little bit of play with this arm where you mount this to. This is able to slide it mount, and also the needle itself. Right, you'll get some distance. So, yeah, I should cover any options. No matter how thin your substrate is or how thick it is, you should be able to test pretty much any thickness. One last safety feature on this. When you're either in the hover mode, say 150 above, or all the way down, or anywhere in between, this contact light comes on. And what that does, it's an added safety feature, it locks the puck out, so you can't move the stage. So, which is a little bit different than that one. That's a safety feature with this one. So when you're all the way down, or even in your hover mode, it's going to lock this guy out from a coarse XY movement. If you go to the 300 micron position, so you're a little bit more above, you'll be able to move the chuck stage in. So in this position, it's going to lock you out. But keep in mind, you can still use the fine. It doesn't lock the fine. It's just designed to lock this, so you can't do any coarse movements. And again, that's just for your probe to paddle line. Okay, and then below that, so this is the table here that the station itself is floating on. There's 4 bladders, one in each corner. There's no adjustment to be made to them. Just for this to float, the air compressor down below has to be on. Nothing to do with the air compressor at all. There's an on-off switch in the front. You can turn that off. It will automatically cycle. So when it reaches a certain pressure, it'll turn off, and then eventually the air will bleed out. of the reservoir, and when the pressure gets to a certain level, it'll kick the air compressor on again, it'll cycle back up and recharge the pressure, and then shut it off again, and that cycle just completely repeats.
So it's similar to 60 psi.
Yeah, 60 psi output. Yeah, exactly. So same as the other one.
Brian,
Yes, sir.
is it possible to stop permanently floating that surface, the black one? This one? It's floating, right?
It's floating now.
Yeah.
Yep.
So is it possible? Like, do you have any option to like stop or not stop?
Like there's an open and closed position here.
No, there's not.
Okay. So it's always gonna be like floating.
It's always going to be floating. Yeah. Yeah, it's not easily done. I wouldn't recommend operating it
So
with it not floating.
yeah. So for this station, then we all should be careful about like touching and more sensitive than it is.
Yeah, any station, like when you're testing
Mhm.
or something like that. Yeah, whenever you have your probes down, your device down, you really want hands off. You know, even with this down, touching it, it's still very, very sensitive to that. It's not going to help. Like if somebody comes over, you know, and they just lean their arm on it, could cause some problems. And the same thing with that one.
Mhm.
Any kind of touching, whenever you have your probes on your device, there really should be no touching or moving, unplugging, plugging things in, resting hands on anything like that. Really want to avoid that stuff.
Okay.
The DC needles, these needles are pretty forgiving. The RF probe's not as forgiving for sure. So
We can also use RF probe here or just DC probe.
it's set up just for DC probes. You can use the RF probe, which you have, but you won't be able to close this up. There are different arms, you know, if you want to in a closed configuration to do the RF. Yeah, I've seen customers they'll have like a little sign, testing in progress, maybe on a magnet or something like that. Yeah, exactly, just so everybody knows.
Yes, there should be some instruction on top of that or somewhere. Maybe on discussion with professor, grad students, and technologists.
Yeah.
So everyone can be aware that how it should work and what should be maintained throughout the testing process.
Right. Yeah. Yeah. You may want something because you're going to have a lot of people coming in and out, and you could be taking a measurement, and maybe you had to go to the restroom, run it, and somebody comes in and just not realizing that you're testing. It's good to have some kind of visual. Yeah. So everybody knows testing in progress. Do not touch. Yeah. Something like that. Because that'll certainly affect your measurement. It doesn't damage your probe. Just touching it's going to affect your measurement. Depending on how sensitive your measurement is, for sure.
What's next?
How do we load them in?
Yeah, the next step maybe.
Okay, yeah. There's a keyboard tray here. As well, so much down below.
Keyboard to do what?
If you we had talked earlier about a monitor for, say, your analyzer or your measurement equipment. You want to output it to a monitor. There's a post, an accessory where you can put a post on. You can have a monitor up there. So you could use a keyboard to control your analyzer or your measurement equipment. If you want to do that. A lot of times, customers will just put like tools here, gloves, tweezers, things like that. Maybe some wipes that they'll put in there. Okay, let's see, good questions.
So how do we load the probes in?
So, does anybody have any questions on stuff? Yeah, we can get going. And
Super.
yeah. First order of business. Sounds like we have a volunteer.
Yeah, do we have more chance to?
Okay. Good morning.
Good morning. Yesterday was very cloudy.
So this is a DC probe arm. Get this guy off of here. So you have a collet here for mounting your DC needle. And then we can look at this a little bit closer too. On the top, you got 2 holes. And if you flip it over, there's just going to be 1 hole towards the front. And the reason for that being is in between these two, there's a channel where the probe needle is going to sit. So when you do clamp it down, it sits right in a channel that's cut in between these 2 slits. And I'll give you 2 different angles. The top hole, the 2 top holes, they both come out the same hole in the bottom, just a couple different angles. One is a little more vertical and one is a little bit more flattened out. And then this cover, it's magnetic also. So when you're setting up, you can have this up out of the way when you're putting it up there, and you don't have to worry about this guy falling down or getting in your way. So, and to mount this on here, there's a thumb screw right there. If you undo that, it's just a hinged clamp. You can completely unscrew it. It's a captured screw, and then it hinges out of the way. And then this piece will go right up against the bottom. And you can close it up again. And keep it, relatively square with your position. That's it. And to mount the probe needle, I recommend you have it mounted on the surface. It'll make life a little bit easier. Get my tweezers.
You need this. I don't need this. Come from.
I think they're there somewhere.
Yeah.
Oh, you have them, okay.
And this goes down. No.
Yeah, so the sharp
In 6 years.
is sticking out.
That I can do.
And then, just push it up from the front. Takes a little bit of force. And then the most difficult part is just finding that channel in between the 2 spots. And once you find it, you'll kind of feel it drop in, and it gets very loose. You
Sorry, you put it through the hole or you push it in?
push it in from the front.
Okay.
Yeah.
Make it a little bit loose, so more space. Then push.
Yeah.
And you push it from the front, not from the
From the front.
Yeah, you can't really come down from the top. If you do that needle, you'll just ruin the needle damage.
Okay.
Yeah, it's easy just to push it right in.
And if there is a click sound,
When it drops in, it kind of clicks, and then you feel it gets very, very loose in the channel.
Yeah.
It's a
we
little,
can try.
Yeah, sure. Oh, we got a second one too. We can do the next one.
This is the chamber. It's isolated from IMF.
From the environment.
Yeah.
From the environment.
Lateral. All right.
Magnetic vacuum. No, the chamber doesn't have vacuum. Does?
No, the chuck surface has that.
Yeah, yeah.
Not the
Just for
Yeah. These are triax probe arms as well.
Unlock.
lock.
There is a unlock. Now you can take it out.
Okay. That's gonna go right up against the bottom. Right on there. Just try to keep it somewhat in line here. Perfect. And let's get this one out of the way. Use that same spot.
Different environments, different. The difference between this and this here.
if the test system has an impact with electromagnetic interference, then with that it can prevent electromagnetic interference. Chip should be on the closed environment, so it will prevent EMI. Yeah. Yes, yeah, maybe too sensitive that test system for analysis. So it can prevent that. That is extra feature for this station. Another feature is that there is a locking options at certain. If you set something, then you can't move that surface, flat surface. That means it is called test-based system. Test-bed, circular flat surface where you put your chip for analysis.
So we cannot do that.
We cannot do that.
Oh, Harry, yeah. That's a good point. You want to have your needles approximately the
You can
same.
lock the system.
Some
locking.
distance.
Yeah,
If you
below
try
the
to
arm,
it will not
approximately.
Yeah. So that everyone is in the
Unless
same
you
level.
unlock that.
Yeah, approximately. So you don't have
So far, that's what I actually
so you don't
hear
have
about.
one like really
But
high.
there
and
should
one
be
really,
some
really
additional
low.
options if we dig down to the user manual for this. There are so many settings, different settings for this.
And it's not good. So now if you want to make fix
This one.
this way, it's coming out, that means pushing.
Or that might close.
Now
Yep.
it's fixed.
That's why it was that one.
Oh yeah, it's when you're in that channel, it's very, very loose.
Brand, what
Yes,
is the technical name of this part? According
Chuck.
to MPI?
Yeah, Chuck.
Okay.
Yep.
Chuck.
You see the chuck.
Okay.
Okay, great. That's it. Thank you. Perfect. All right. Let's see. Now, I'm gonna have to get up here for this part. Covers for enclosing. Some of the covers are solid, and some of the covers have an opening in them. So I'm going to be using a positioner. Gentle.
Now it goes inside.
It goes inside, yep. And you want to have kind of eyeball where your needle is, bring everything towards the center. Start with your positioners, X, Y, and Z, centered, and alignment, and then bring the tip of the needles somewhere near center. You only have so much room to go with the microscope. Basically, you're going to operate in this zone. So when you're setting everything up, putting everything in, move everything towards the center. So I'll do the first one. So I can look down. These covers are in the center for left to right, and then front to back. These covers are in the center. And to me, that looks pretty good. I'll do the first one. Cover. These covers are magnetically attached. So that's going to be number one. Anybody want to take a shot at number two?
level, this edge, right?
Yeah, try to keep the arm like centered in the gap here as well.
Yeah, in the middle.
Yeah, around the middle, and then, oh, shot, oh no. I think I just caught on this probe. Oh, oops. Oh dear. And these will poke you. If you catch skin, it will go right through. So I'm going to destroy that needle, but that's a little teachable moment. All right, looks good.
Yeah.
All right. Next volunteer.
Good.
Okay.
You have to unlock
Okay, yeah,
it.
you got it.
Unlock this
There you go.
portion.
Got it. Try to keep the shaft kind of centered in the slot there a little bit. Once you have it where you like it. Perfect. And then you can lock down the magnet. So it move. Perfect. Okay, all right, excellent. Want some more?
So that's why I was asking you first and then
Oh, yeah.
He didn't know it.
So, slide a little bit, the shaft of the slide. Turn it a little bit into the needle. Pretty good. Okay, great. All right. So if you want, we'll have the cover right next to you. So it's 4 captured thumb screws. And it can go on that way or spinning it around 180. It's the same. All right. Right. Last one. And actually, I'm not gonna touch anything. I'll let you guys drive. So if we zoom out, did we talk about the zoom on the scope? A little bit. There's a zoom. Zoom out. Sure what that is, maybe the edge of the chuck somewhere. So it's I do see a shadow of the needle right there.
No, it's always there.
Pardon?
It's inside, it's always there.
Yep, yeah, this is the pro needle.
the middle.
So if we, using the coarse focus on the microscope right now, we're zoomed completely out. And then if we move, the focus up, we're gonna see at least one come in. Yeah, there you go, yeah, keep coming. Keep coming.
More.
Yeah.
That's the middle.
Yeah, one right there. So the trick is to find the other ones. On the right side there, you have 2 black knobs. You're good. And you can move it X and Y. There's a silver thumb screw on the side. Yeah, loosen those a little bit. Yep. You can still turn the knobs even with those locked. So we got one there. See if we can find another one there. Drive around a little bit. X. There. together. One.
No,
Oh,
two together.
okay. Those are very close. Maybe if you try to
Focus.
focus
Focus to
again,
see.
see where they are. Those look like they're very close.
Oh, my
Oh, it's on my shirt. It's not too bad. So that's probably a pretty good starting point. It's very nice to have two right next to each other. Those are really close. And what we can do is gradually bring this one over.
We can also move the needle, right? Up and down.
Yeah, exactly.
So probably
First we want to
these two ECS and this
Yeah.
one with the other one. So maybe you can move a little bit.
First, we want to bring it over a little bit, and they're quite a ways away. So let's try something first. It's a little better each time. So, let's see some of those two. Oh, you know what? That's interesting. The image is flipped.
That's why I was asking, because sometimes the camera, you have to turn it.
Yeah, so you can change software. I'll show you guys how to do that. So what we found is on the screen, it looks like it's these two, but it's actually these two. So the image is reversed. So let's correct that first. If using the mouse down at the bottom, and then one of those is a flip. I think that one rotate. Yep. Click it once, it'll go 90 degrees, and then second time, yep, perfect. All right, so now we're good. Let's see here. Next volunteer. It's probably because they're so far apart.
Manually,
Better
you
to
can-
physically unlock the magnet and physically move them a little closer. You can do it with the X-Y positioner, but you're going to have to move them an awful long way. And run the risk of running out of
We have to do
adjustment.
manually. Then we'll do the fine adjustment later.
So you might be able to get there with
Yeah.
the adjustment, but you run the risk of
Close then.
running out of adjustment.
Yeah, this tree is very close.
Oh, is your very close? All right.
Yeah.
Perfect. Ah, okay.
Another one.
All right. Let's find it with a microscope before we start turning, because it could be like up here, you don't know.
What is that? Yeah.
Driving in there. It's better to move the microscope around and find out where the tip is exactly. Ooh, there was
Yeah.
oh, and that's exactly where it is. Oh shit. That's all right. That's the one I ran into my shirt anyway.
Okay, so we need to bring back.
Yep.
So we have to bring like x-axis.
And the X.
Exactly.
No, the,
Move the needle to x-axis.
So,
Yeah.
So scary. Oh wait. Okay, stop.
So you don't
You
touch.
keep going back. Yeah, you could run into the other probes. You have two other probes here.
Yeah. So it doesn't crash with each other.
Yeah, absolutely.
it's fine.
That is fine. So.
Okay, that should be okay. And let's see. Let's go back to where maybe we can get them all in view now.
We can break one or two unless otherwise we cannot.
All right.
Don't break the RF one. $2,000.
Yeah. Okay. Whoa. Okay, yeah, it's quite a bit out of focus. So the z-axis on that same probe.
Well, we don't want to make them together, right? We want to put in different pins of the IC.
Yeah, definitely.
Maybe can you
For
put
this,
something?
oh, look at that one. It's got a little something there too. But yeah, exactly. So at the moment, get everything in view and get all the probes at the same level.
Yeah.
You know, so that's the best starting point.
What is that?
That's a little, it's been modified a little bit. Let's see. And also, those z-axis screws, they will come out. Actually, all of them will come out. If you screw them far enough, they will unscrew out. We do run out of room. Still got a little bit.
Actually, they are not at the same level.
Yeah, they're not the same level. So that's the first thing we want to do. So this one maybe needs to come up a little bit. Come up? Yep. Come up some. And there's also a Z and then an up on there. Yes, keep coming.
No, making more clean.
Yeah.
That is coming to same level, right?
Exactly.
Because it will focus at a certain level.
Yeah, that's critical. Yeah,
Yeah,
that's
that's
pretty good.
Yeah.
And then maybe the other two also on the left and on the left side.
Another way. Oh, sorry. Yeah, there.
Yeah, pretty good. And then
Yeah.
one more.
The corner one. So now they're the same level.
They're all at the same level exactly.
And there's the question was that by the ground yesterday, how do you put the needles in a same level?
Yeah,
Yeah.
yeah, exactly. That's a tricky part. And because we're doing it with focus, so they look like they're all at the same level, but when you're actually touching the device, it's going to be a little bit different. It's not going to be exact. You can zoom in a little bit too. But the real test is when you actually put it down on a device.
Yes.
Absolutely.
So can we try with something, I don't know, we have a small
Oh,
tube.
you have something there?
Yeah.
Okay. Before we do that, we're gonna lift up the chuck. The chuck's already up, actually, so we're good to go there. Wonderful. Can we focus on the chuck? So if we put the microscope down, and just to reiterate, there's two positions for the chuck, and that's pneumatic control, and two positions with the Z-axis. Put it down. We'll lower the chuck down to a lower position, and it's designed to bring it forward. And loading your substrate. Here, give it a little bit more access, and just so you can see what's going on, when you raise the chuck up, it's going to be in a higher position. No, I don't know the exact distance. It's probably about 10 millimeters or so. And then there is a fine Z adjustment here as well.
So it's better to work with the higher positions with the chuck.
When you're probing, yes, absolutely. The lower is only designed to aid loading, you know, keep
Yes.
your probe
By
safe.
mistake, if you work with the lower positions, with the touching the probes, and someone by mistake hired the chuck and you will hit the knobs, right?
Yeah, exactly.
So
You know, when you're probing, you're always at the top. You know, maybe you can even make a little sticker note here, you
Yes,
know,
yes.
probing position, something like that. Sure. Okay, yeah, we can throw your device on there.
So throw this here.
Ready? We're gonna do the chuck first.
Pretty, yes, we do want to focus on the chuck. That's pretty
And then
thick.
when we have a foam over here with the pin, how do you?
It's very, very thick.
This one. Because that's what we have. We already integrated this.
Let me think. I think we can. What we can do, it's not the normal mode, but just because it's so.
Yeah, because I was expecting Professor maybe come with the chip, but nobody shows up. That's what I have.
So just to be safe, I think we'll start in the lower position, because in the upper position, yeah, I don't know if we're gonna have enough. It's gonna be very, very close.
One sample I can bring it. It's not.
Oh, you can bring one sample?
Yeah.
That would be great, yeah.
Yeah, it's
Oh, so
like
yes.
carbon.
Okay, that would be very good.
Okay, well, I was getting that, yeah, if you
Yeah.
go ahead and focus on the chuck.
Yeah. Because...
You wanna go?
No, I go ahead. I just want to put this.
Okay.
Because I will get a lot of chance to adjust later on. I'll be here.
And then the next step would be to lower the platen handle. So we're gonna bring everything down to the bottom and watch your monitor at the same time. It may be locked. I think it is locked. Yeah. Yep, you got it exactly. And then watch them come down. and be nervous if they start to come into focus. I think you got enough room. I think you're good. So you can drop it down more, and then the hover handle right next to it, you can drop this one as well. Yep, exactly. So it looks like we're safely above the chuck surface.
So how can I move this one now altogether, or up and down, or do I move
yeah.
the chuck?
If we're gonna load the sample, yeah, we move the chuck down,
No.
and then,
Now the needles are way above the chuck.
yes, yep,
Can I lower them all together, or do I have to do it?
one separate, yeah.
One by one, like yesterday, yeah.
Exactly. So what we would do is put the device in, because that is gonna be, it's a thickness too also, and then we can focus on the device, we can focus on the needles, and then we'll slowly bring everything down. Yeah. And you may ask, well, why did we do it before? Why do we make everything level? It's always, for me, it's the safest to know where all your probes are before you start, before you do anything. So you're not blindly driving around, and less chance of an accident when you have something known, you know where they are, for sure.
And we enter this position with this lever down, right?
Yes, so if we're gonna put probes down, yeah, this guy down, and you can move it up and focus on them, yeah. So, do we need an instrument or anything to plug into with
Do
this
you want,
device?
do we want to, or,
Gonna make a measurement?
okay, if you can bring
A
this.
simple measurement or something, sure.
You have the set here, right?
Yes.
This guy, yeah, right there, you got it. And so it's gonna be the chuck, if you wanna adjust it, oh, sorry, one moment.
Yep.
Just on the chuck itself.
No, that's why I was focusing on the needles, so I can bring the chuck as far as close to the needles.
Oh, you wanna do
Instead
that?
of lowering each one of them.
Oh,
higher
okay.
the,
okay.
no,
Give it a
if it
shot.
has trouble,
Yeah, a little closer.
Yeah, it's a little ways, it may not have the trouble.
I'm just checking out if I can do that.
Sure.
Instead of getting down one by one.
Yep.
Bringing the chuck up, but not the travel, I don't think so.
Well, you may be out, I think.
Yeah.
I'm not sure if that's gonna drop out. And there's also an indication scale.
Oh,
When you're at the limit, and yeah, we're at But the right idea though, for sure.
Yeah. Less work.
Yeah. But perhaps with a device on there, it may give enough thickness where.
Yeah.
That will work.
Yeah.
So these steps are mentioned in the user manuals, like what the steps we should follow.
Not so much. It shows you what, obviously what the features are. I don't know specifically, to that detail steps, and there may be some rough steps, but it'll show you all the features and everything. But it's really your best practices and what you come up with, and your best way to operate.
This is how.
So we use this with tweezers for the ICs, or?
Sure. Yep.
So it's better to start with the needles as low as possible. Because I took the Z axis all the way up and the loose came.
Oh, you can't touch?
Yes.
Ah.
So we better put the
More
needles
down?
more down, general stuff, not even center.
Let's try and put the device on first, and that's what I was
True,
saying,
true.
but yeah, maybe, I'm not sure if it'll give us enough or not. I hope it does, if not, then we'll have to do exactly that, move all the needles down. That's a long ways, huh?
Yeah,
Let's
it's a
see.
good one. That's okay.
I think you're right, I think you gotta move the needles down.
Use soft tweezer.
So what is the purpose of this plastic?
Oh, it's just so you can't scratch the chuck. Yeah, it's for loading devices. And just so it won't scratch the chuck surface. Oh, you have to chuck down? Pull it all the way forward. Now, I gotta turn the vacuum. Reach the vacuum pump. Yeah. And then, first, we'll, no, down. We're gonna turn the vacuum on. So there's check vacuum on the side. Here. You can turn that on. And then you can poke your device a little bit to see if it's got vacuum, see if it moves. If it seems to be okay.
It's moving.
Does it take some force or
Yeah.
is it takes a little bit? Yeah, as long as it's got to grab a
Because
little bit.
this hole, so vacuum is pulling it.
Yeah.
So it doesn't move.
And it's just those 4 holes. We could do the 2-inch, but then you're gonna have a vacuum leak. So let's try it with that.
Because this is
Let's
big,
go first.
big wafers, so probably we can
Yeah.
use the 4 or 6 inch one, yeah.
Yeah,
4
you
inch.
you could, yeah, excuse
4
me,
inch
yeah,
would be-
4-inch. You could do
Six,
that, but
okay.
then you're gonna have a leak and stuff like that. So let's try it like this
So
first.
also how we can get where the points are, of the vacuum points are.
You can see there.
It's hard to see if you have trouble seeing. You can cheat a little bit. And you can see, oh, it's, yeah, put an angle too. Do you want it at that angle or should it be?
Yes.
Better to have horizontal.
Sure.
Horizontal.
Oh, it's like a 45 horizontal.
Better to have.
So these points are very center of the disk.
Yeah, at the very center, so yeah,
That's
exactly.
that's the way we can guess where the points are.
Yeah, and they're very, very small.
Oh, still, that is sticky something?
Yeah, it's sticky, yes.
It doesn't move.
Oh, does it move? Oh, it's like tape that, okay.
Yeah, tape.
The holes are in the center in general.
Yes, so you have the holes right in the center,
we can
and you have
bring
a
it- bring
4-inch
it out.
ring.
I
6-inch ring.
Yeah, you can take out the tape. You don't need the tape. Keep it. Yeah.
Ah. You also have to be careful with like tape on some devices. If the tape is above or curls up over the height of your device, it's possible when you're moving the chuck, you can hit the tape.
Scissors.
It's possible you could hit the tape on the curves. Push it hard enough, it will move.
I'm not sure if the vacuum is on.
Oh, yeah, I heard the vacuum pump change, so vacuum's definitely on.
The choice is moving, so it's not.
Oh, because we're in contact, actually. So we have to do, if we want to move the chuck.
Let's put in the center.
Yep, so maybe
That's the center. Just really low.
very,
Not quite strong.
one substrate is fixed like this one.
These are the 4-inch one.
This is like a tape. It's got something in the center, but it's not very strong.
Yeah, it's, you can continue maybe. Yeah.
Should be all right for Okay. All right, we're gonna pretend that we got good vacuum and it's on there. It could have something to do with the tape if it's got any ripples or it's just not flat. It's gonna be hard to grab vacuum as well.
Yeah, surface is not very much in contact with the chuck, so.
Yeah, and we're not only dealing with those 4 small holes to begin
Yeah.
with, so any little bit of leak is going to be tough. So, all right, you guys got a
So
challenging one. So now you can go down, and then you can go up to the chuck.
The scope goes down.
And the scope goes down, Expert at this. All right, wonderful. So now, let's see, we need to move kind of off in that direction a little bit, but in order to move, we're going to have to just put the platen handle at our 300 micron position.
Because the IC is here, so
You gotta move it, but with platen handles down, so it's going to be interlocked, but you can go ahead and put it up in the first notch up. Put your 300 right there. Right there.
now
And now it'll move. Yep. Yeah. So it looks like I made the order device and do that. Perfect. And the next thing would be to focus on the device and figure out what our finds are.
if you want to move this little bit, the chuck with here, right?
You can move it.
Maybe a little bit zoom out.
Hope we're all the way out. Yep.
We're all the way out. Because I'm not sure which one is the pad.
Well, we can move this that way, and you can move the course one if you want to drive around a little bit. Almost looks like T or something.
What's the angle?
Oh, that did look like the theta. Yeah.
Is-
Then that's going to be your Z. There. And then right here. You're probably better off. I think we're in the middle of nowhere to just drive around. Maybe on tape.
There's the IC, so
Really?
these two. So there's going to be 1, 2. I don't see the pad, like the.
No, actually there's, I haven't made any.
Oh, there's no pad.
Yeah, yes, you can put it in, that's okay. Because it's a rough sample, it's not our regular.
Because if it
Yeah,
doesn't,
it's like the very initial stage of this program.
because if it doesn't have pad, we cannot put the probe. We need to probe the pad, right?
To make an electrical connection?
Yeah, I'm trying to, the very initial stages, the sample is very strong.
Oh, okay.
So we can try here. So we can calm it down. Let's try with this.
Yeah, we can try it out on those guys right there. So you can add your needles there, and you can now put this guy all the way down. That should be touching it, so you guys touch
Yes.
it.
So Z,
And then with your probe needles,
just put the Z down, right?
exactly. Hopefully we have enough range. And then we should start to see it come into focus. At the bottom,
Yeah, it's a long way still. Almost coming out.
oh, okay.
I need more space.
Yep, we're not even close then.
So that's what we're discussing. We need to put the needle maybe more lower.
Something there.
Close.
Let me go up with a new,
Because this can help.
whoops.
No other way to bring up the chucks.
Oh, there it is. I'm not convinced that's not down.
So we have this 5mm.
Trying to find, see where our probe tip is exactly. It's right there. No chance yet, so I'll have to extend.
Should we get the 5mm more?
So we got, yeah, actually we got quite a bit. So this is gonna be the bottom, and then there's an indicator right here, so we do have quite a bit.
Yeah.
Yeah, we can try that, so we can put this on the tip. I don't know if we'll have enough there or not, but then with this Z,
See.
yep. You can rotate it, and you should see that indicator start to move up.
So go down, right?
Up.
If you go right side, it go down. But
Oh,
this is the chuck.
there you go.
Last we're watching the chuck. This is the chuck, right?
Yes.
Oh, yes.
Yep.
Let it go up. Yes.
It's coming. Yeah. Do we have enough? It's gonna be close.
I'm going little by little.
It's gonna be very close, I think.
Almost there. Yes.
Yeah, almost.
Maybe now we can try with the needle.
Yeah, we might be able to. It's pretty close to the bottom. Yeah, we're almost there.
Yeah.
Okay. Oh, yeah, you just moved it.
Yeah. Touch it,
You
right?
pushed it around. Yeah, yeah, you saw the device move. So.
But there's no shadow like
So,
before,
yeah.
so we can.
Yeah, when it's a little trickier when you have that dark background. Like
Yeah,
that,
that's-
very, very tricky. When you have circuitry, it's a little easier to see the shadow. Really bright or really dark background, it's a little bit challenging.
So in these positions, if we want to little maneuver, we can take this out, up,
Mhm.
and we can move the chuck down in this, right?
Yeah, exactly. If you wanted to move around, easiest thing, switch, and then your probes are safe. And then you manipulate the chuck around, find your next spot, and then you can bring it to the 300 millimeter position, and your 300 micron position, excuse me. And then you can still move it around a little bit, which is fine.
Fine.
Yeah, and then if you want to do a little finer positioning, I think that's actually block now with a contact lid, then you can still refine adjustment.
It hit the dot.
Yeah, a little bit, and then finally,
Now we'll try the same one maybe.
sure, yep.
And yes,
You
you try.
know, good job.
See,
That one's gonna be real hard to see because of the black background.
Yeah.
You may wanna focus the microscope on the probe tip and then moving the probe tip and the microscope down at the same time. Yeah, that's hard, that's right here. That's really, really difficult. That dark background. That's got some challenging stuff. And then you can drop the needle and drop the microscope at the same time. Exactly.
Can you have the scale over the screen? The scale, what's the
For size,
yeah.
size scale, not really, because the scale is calibrated, and with a different zoom,
Yeah.
there's no way to do a scale.
yeah, it's difficult for the black background.
Yeah, very difficult. That's a tricky one.
I see the point here.
Can you see it?
Better to try with that one,
Yeah. Oh, maybe, yeah.
right?
Yeah. So it might be a little bit easier. Yeah.
Yeah.
So take a little bit of practice.
Yes.
I suggest, yeah, get on there, and you're gonna damage probes. It's gonna happen. Don't sweat it too much, but just use some garbage stuff that you can just play around with. You know, and spend a couple hours just getting used to
Yeah.
the system, try all the features and all the buttons. Absolutely. Oh, is it done?
This is the highest.
Ah. Yeah.
Now
Right
what is
over.
the biggest one is touching already.
Yeah, the other one's touching. So what you could do is, if you can still do the chuck Z up a little bit, you can raise the other needle,
Mm-hmm.
you know, and then bring the chuck
Alright.
up
Let's do that.
to the higher needle. But the best solution is probably, you know, all the needles, just adjust them all
Send-
down
send
a little
them.
bit. Yeah, because they're really, really close to the limit. Exactly.
There is the highest position of the chuck.
Oh, it is? Okay, yeah. Yeah, that's probably the best thing to do is take all those needles and maybe lower them an additional 5 or 10 millimeters. Make it maybe. Very close. That's very close. Ah.
And then
Ah! Oh dear.
little bit.
So close.
Mistake maybe broken, right?
I think it's some material.
Material.
I think so, that's stuck on
Carbon is there. So
it. Yeah.
we worked with the the calibration substrate yesterday. Maybe when it touches that one, maybe.
Could be, yeah. Take a little material, or it might have been when we touched this device.
Yeah, it's all the
Yeah.
black, so like black materials.
is kind of understand the concept and the idea.
Yeah.
Yeah, spending a little time. Nothing like just getting it on and playing a little bit.
Yeah, we will have like these types of very subtle challenges. Like now, the challenge we have when it's touching, and we almost reach all the positions.
Right.
That
Yep.
means now what we can do, just lowering the needle, taking out, or
Yeah, so what you do is raise up the platen handle, and you probably want to raise up all the positioners, okay, we know, and then take them out and then lower that needle. Extend the needles down a little bit. And then when you come back in, just be mindful that the needle's now quite a bit lower. So first thing you want to do is just find them with a microscope. First, finally, you just get them at approximately the same level, and then just go through the same process.
so probably it would be better if we can make the needle more lower, like not too much, right?
Yeah.
So that because we have more space to adjust.
Right, exactly. Right now, we have the chuck is all the way up, and the positioners are all the way down.
But we have the needle is more on the top, so we put down more so that
Exactly, yeah, so you can extend farther, lower,
yeah.
and then start, reset these, put them all the way up, maybe put the chuck all the way down, and then bring everything back up into contact.
Well, you get the idea, like
Yeah, get the concept and stuff. Not something you really want to rush. Try to do quickly. It's easy to make mistakes and stuff. Take your time and spend a little time playing with it. And then, yeah, it's really, really easy.
So we're doing the same thing actually. It's a DC and this RF.
Same thing as far as touching the probes and moving the device
Yes, I do
around.
the externals.
It's essentially the same thing. Yeah, just a couple little differences. This one, the contact is probably the biggest difference, and also the chamber.
One question is like for the DC probes, we have like one needle and it's touching the pad, right?
Mhm.
And we're giving external signal. For the RF probe, we have three. You say one is ground, one is line to ground,
Ground signal, ground, yeah.
ground signal, ground.
Typical, yeah.
So
The
this three goes
center.
to like if you have regular chip, how do you connect this RF probe to one pad? Like how is the connection?
To one pad?
So it will be three pad even. How do you connect the RF probe? Because I didn't work with them before.
Typically, it's three pads, yeah.
So for the RF, it will be separate pad to connect. Oh, okay.
Yes.
For
yes,
RF, I see it will be different.
Right. So you have two ground pads and then you have a signal pad, in the center. Exactly. Yeah, that's kind of getting into the weeds a little bit. It's pretty neat stuff, the RF stuff.
And regarding the calibration substrate, I mean, what is the purpose of that? Like, what do we do with this substrate calibration?
So my understanding with the calibration substrate is, the probe is going to have certain characteristics. The cable is going to have some characteristics, and even your SMU or your measurement equipment is going to have some characteristic. So the idea of the calibration substrate is you perform a calibration of your instrument, your cable, and your probe. So when you're testing your device, it makes the probe, it makes the cable, it makes the instrument invisible. So the only thing you're measuring is the device itself. So it kind of cancels out, any effects from the probe or the cable or the instrument. It kind of negates any effects like that. So the only thing you're measuring is what's actually on the device itself. So hence the calibration substrate.
How periodically should we do the calibration of this? We do the calibration only for the probes, right?
Yeah, I
No idea. Like,
I don't know. Yeah.
because we have calibration module for like PNA or other equipments for calibration with their recommended like every certain period we do the calibrations kind of stuff.
Right. Yeah, it's a little bit different than like sending it out for calibration or something like that. This is like, I think like if you change your cable or you change your probe, maybe a different wafer.
Different setup.
Yeah, a little different setup, and it's just to make your setup invisible. So you're not having any influences from the cable or the probe when you're measuring your device.
And regarding
You're very
the
quiet over here. You have any questions?
Not yet.
Not
I
yet?
have one question. Basically, I am from power system background.
Mhm.
So in my most of the cases, whatever let's say equipment coming from wherever, there is in every website in their system there is a section for knowledge base. That means from there we can collect as a customer or user we can collect different resources which actually represents use of any specific equipment.
Okay, yeah.
And different for applications. With this machine, we can do different things for analyzing of a chip, right? So I am wondering that I did not go through the website. I believe there should be different resources for this machine.
Yeah, for example, it can be used for characterizations,
Yes.
for noise analysis,
Yeah.
for a lot of purposes. Yeah.
Yeah. So yeah, for example, for characterizations, maybe from the company they did some, let's say for very basic characterization things with the help of this
Machines.
machine. So maybe there is manual in instruction manual or a paper, white paper, which actually represents that characterization, and which also use this machine. So maybe I am assuming.
I talked with this Thai yesterday.
Yes,
I asked
so-
him because if we can provide some like background materials or like steps, because I did not see the user manual yet. Probably there should be something. If not, probably we'll ask him to give us more feedback, like more materials regarding describing the steps and the use of the machines.
So if we
Yeah.
get that, then it is not only helpful for us, then also for grad students or undergrad students or even postdoc or
Yeah.
faculty member.
Absolutely.
You are as working as service engineer for there, and you have so many connections
Mhm.
in your department and for other department. So that could be another resource for us.
Mhm.
It's
To
very
get.
helpful in a sense.
Yeah, no
Because
question.
we don't know all the
absolutely.
features.
Yeah.
You know, you just show us this. Out of that, we don't know, no idea. Right?
So certainly, yeah. So the user guide, I did send those to Ty. So for both stations, so he should be sending that to you. So, but the user guide is just general information. It's like a user manual for your TV. You know, it's this function, that function. But as far as like
The knowledge
taking
base and
measurements
backgrounds,
and
yes.
specific information,
We can take
that's a little bit different.
Yeah.
Yeah. So, but Ty can get you that information. Though.
Okay.
Okay.
Whatever questions you have, direct them to Ty. Yeah, he can get you the answers for sure. So for
yeah.
the user guide, yeah, it's more of a hardware and the accessories, the positioners, the microscope, the chuck stage, and the features on the station. But
The reason we are concerned about this because at the end of the day, maybe not this time, maybe let's say after 1 or 2 months or 6 months, professor may ask us because we are as technologists, build some informative manual which can be extracted from user manual for them as well as for their students.
right.
Yeah, so that is little bit technical and it's time consuming to do that. So if we get some background information resources, just I talked about, then it would be seriously helpful.
Sure, because you got new students coming in all the
Yes.
time too.
Yeah.
Every
Yeah.
year.
Because we're at the starting point of this. Like they will ask us how to use these machines and how to work with. So we have to make some format to provide them so that they can start working with that.
Absolutely, absolutely, and that's important. Keep it consistent too. Year after year.
Because as long as you are here, we are feeling confident that okay, this is how it works, and this is how we can switch or go through that.
Mhm.
And then when you go away, then we are still trying to do the same things, but there definitely will be problems.
That's when the
Yes.
questions come for sure.
Yes.
When you start to use it. Yeah. Encourage you. Yeah, if like a bad device or old device and probes, and sit down, spend a couple hours.
Yes,
just playing around.
It's all about, I think, giving time and investing different exercise.
Yeah, investing time, just sitting down, because you don't know when you start doing. And I'm like that very much so. I have to put my hands on it and actually do it, and that's when it starts to reinforce, and that's when I really begin to understand it. Once I get my hands on it,
It looks stable now. It's not moving that much like that you were showing before.
it's all the light intensity. It's all this light intensity. I'm gonna feed that back to the factory, You turn the light, right now I have it very low.
Mhm.
You turn this up, let the camera adjust.
Seems good.
It seems to be
Yeah,
it's
It's
the vibration.
better.
Yeah,
It's
no
better.
vibration. So
It's better. I would encourage you to keep it just at a low light intensity. For sure. Yeah, we should probably plug it into this other monitor too.
and another thing, what is the use now of the chamber, like the EMI chamber, because the shield.
Mhm.
So we do this almost same thing. So what would be the use of this shield for testing like different ICs?
Yeah, different measurements. It gets a little out of my comfort zone because I'm not an expert in measurements. But anything that's can be influenced by lights or cell phone or wireless repeaters or anything that you might have in here.
Because
Any
we
devices?
have like optoelectronic sensor as well, so which is dependent on the light. So yeah.
Oh sure, yeah. Anything for all that stuff, depending on how sensitive your devices are. Some very sensitive devices will be influenced by any kind of
Like
radiation like that. So
like
that's
these photodiodes, phototransistors. These are very sensitive to light, so we can.
Okay. So that's pretty much what that's designed for, to kind of block out the outside world, from any very sensitive devices. Absolutely.
So
That's the primary function of it. And if you had a thermal system and you wanted to do cold, cold temperature testing, so that can provide an environment where you can probe, below zero and not have any ice or anything like that as well.
So is there any other feature you want to show us, or that's it?
That's pretty much it. We should go over the list as well. I can show you.
And
make sure
I'm thinking I will also check with Julia regarding the positions. If she agrees, probably I can move the wire button now and you can fix the positions right now. Because once you leave, it's very difficult for us to move and fix the lever.
And then level it out. Yeah, exactly. Just put the level right here and right there. And just use the feet to level it right out. Yeah, really easy to do. The floor looks pretty good. So you may not have to adjust it very much at all. So, and it doesn't have to be exactly level. You get it close. Pretty much. All right. Actually, I can get the list of stuff.
So you.